Okay, hello, good day class. Nandito naman ulit tayo. We'll talk about strength of materials for our integration course for machine design. Now, ano nga ba yung mga thoughts na pag-uusapan natin pagdating ng strength of materials? So, let me just go to my notes and then we will proceed with our discussion. Okay? So, this will be so let me just check. Okay? So, strength of materials. Ano nga ba yung mga pag-uusapan natin sa strength of materials? Number one, ang pag-uusapan natin dyan is the effect of forces into a given body. Ano nga ba nagkakaroon dyan? Okay? When a force is directed to any body into its uh, cross-sectional area, okay, meron tayong iba't ibang uri na mabubuong stresses. Okay? By definition, a stress is the result of a sudden application of force through a member which has a cross-sectional area, okay? Perpendicular to the cross-sectional area. Now, meron tayong iba't ibang uri ng stresses. What are those? Number one, meron tayong stress na compression. Pagdating na compression, ibig sabihin, that is pinupush to its fiber, okay? Kapag tension naman, that is pulled. Kasi ang compression is a result of push. Tension is pull. Ang bending naman, you push it with the uh, counteracting members sa dulo-dulo. That is parallel to your cross-sectional area. Torsion, you twist. And then shearing. The shearing is the result of two counteracting forces. Ibig sabihin, mapupunit pagdating ng Tagalog. Okay? So, let's go with the types of simple loading. Now, what are the types of simple loading? Meron tayo dyang tension, meron tayong compression. Where your tension is the pull of forces, the compression is the push of forces. By general formula, we denote stress as S, F is the load or the force, and A is the area, cross-sectional area of your material. Now, ang pinag-uusapan lang naman natin pagdating ng ating stress of or strength of material is number one, pwedeng mga circular objects. Number two, quadrilateral objects. Okay? The common quadrilaterals na pinag-uusapan natin dyan using beams ay yung mga rectangle and then squares. Okay? So let's just focus muna dun sa circular beams, okay, or circular materials. So, meron tayong area. Going back to your solid mensuration or geometry, ang area for solid circular, that is pi over 4d squared or pi r squared. Ngayon naman, for hollow, ibig sabihin may butas, okay? The section is equal to pi over 4 multiplied to the difference between the square of the outside diameter minus the square of the inside diameter. Okay? Or pi multiplied to the difference between r squared minus yung maliit na r or the inside radius squared. Now, sabi dito, for ductile materials, ductile, okay, so you go back with your materials engineering, ano ba yung ductile materials? They are the materials na kapag pinound mo or para mga wire, you can turn it into wire, okay? So, if no deformation, what is SD? Okay? SD is the design stress. SY is the yield strength. And NSF, what is NSF? That is the strength factor or factor of safety. Okay? Where will you get this? Depende sa material yan. So, you will have to check that into the tables of FAIRS, yung machine design of elements. Okay? So, you can check that for AC 1020, yung mga ganun. 4310 na materials of steel, but iba ang nandun sa table na yun. So, you have to check that if given, okay? Now, for deformation, okay? No deformation, ang gagamitin mo, itong SY, okay? For deformation, ibig sabihin, magbabago na yung iyong material. Nag-deformation na siya or nag-deform na, wala nang, hindi na siya, lumampas na ng elastic limit niya, okay? So, ang tawag dun is the strength curve, okay? Ngayon, pag nagbago na yung material mo, all you have to use is the ultimate stress of the material. And that is also different from different materials, okay? Magkakaiba yan. Now, for brittle materials, ang gagamitin mo pa rin, SU pa rin. Kasi pag brittle, may tendency yan na masira na. Okay? Sila naman ang pinagkaiba nila. Okay? Now, we'll talk about bearing stress. Ano nga ba yung bearing? So, meron kang dalawang bagay na kung saan meron kang plate, meron niyang, ang tawag doon, slot. Ang bearing is nagkakaroon ka ng slot due to the loading. Okay? Due to the pull. Yung slot na yun yung parang ganyan, yung slot na yan, yun yung butas na lumalaki habang nagkakaroon ka ng loading. Ibig sabihin, due to the pull of forces of the plate, okay? On the plate, nagkakaroon ka ng stress, nagde-deform siya, okay? So, what is the projected area pagdating ng plate na yun? So, the stress or the bearing stress or SB will be equal to, okay, force over the projected area. Now, what is the projected area pagdating ng iyong bearing? Now, when we're talking about yung material natin, tignan nyo ito. Meron tayong thickness of the plate, meron tayong diameter of the hole. Now, ano ba yung nagpo-pull doon? Okay? Ano ba yung nagiging slot? Okay? Hindi naman yan pi, hindi yan yung circle. Okay? So, the affected area will be yung circumferential distance ng iyong plate or ng iyong hole and then its thickness. Okay? So ano ba yung circumference? You go back to your geometry. Okay? The circumference is pi d. Okay? And t. Bakit po naging ganito, sir? Okay? Tignan nyo. Yung circumference ng ating circle, yan. Diba? Circle. Ngayon, pag iminove mo yan into a slot, okay, ano ba yung affected dyan? Okay, meron kang thickness ng plate mo. Ibig sabihin, itong thickness ng plate mo, i-translate ko ito into a shape or a projected area that forms a rectangle. Okay? Where ito yung iyong circumference. And this is your thickness. So, kung ayan ay length times width, therefore, that is pi dt, pag bearing stress. Okay? Are we clear? Now, let's go to our shearing. Ano ba yung shearing? Okay? You go with your scissors, okay? When two cutting bodies, meron yan, nag-apply ka ng force dito and nag-apply ka ng force dito, and then this is the material that you will shear. Ano nangyari sa material? Sabi nga nung college professor ko, nasisira. Kapag nasira siya, ibig sabihin, meron tayong dalawang uri ng shear. Marami tayong uri niyan. Pero let's focus dun sa dual shear at yung single shear. Okay? Kapag scissors, meron yan dual shear. Scissors, gunting. Okay? Now, meron tayong shear on rivets. Okay? Ibig sabihin, dalawa yung forces na makasisira ng iyong material. Pagdating naman dito sa iyong clevis ang tawag dito. Okay? Meron tayong double shear. Ano ba yung double shear na yan? Ibig sabihin, affected itong part na ito, at itong part ito ng force. Okay? Now, for punch, ano ba yung punch? Shearing, puncher. Okay? Shearing pa rin yun. Okay? Ang gagamitin mo dyan, depende kapag sinabing puncher, pag sinabing clevis, ito kasi clevis to, double shear, Ito naman, in rivets, double shear. Okay? Ngayon, titignan mo parati yung projected area. Okay? Ito, pag projected area ni puncher, projected nito, dalawa, F divided by 2. Projected area ni rivet. Okay. Magkakaiba yan pag shear. Okay? Kaya ito yan. Yung shear will be equal to the force times projected area. But take note of the keywords, okay? Rivets, clevis, and then puncher. Okay? Magkakaiba yun. Now, for bending and flexural, ano ba yung bending and flexural? Ibig sabihin, i-flex mo. Okay? Be-bend mo yung material. Babakliin mo. Okay? Babaliin mo. So, you'll have the deformation. Okay? Meron kang loading, ibig sabihin, itong part na to is the projected bended material. Okay? Ito na yung naging final form niya. Okay? Depende ang magiging bending mo kung saan ang position ng iyong force or the application of the load. Now, let's go with the deformation para madaling tandaan. Okay? Yung iba, nung ako nagre-review, ang sabi nila, PL over AE. How will you remember that? Okay? Meron silang mnemonics. Okay? So, let's use that. Nung ako nagre-review, thank you to my reviewers, sabi nila, si Pauline Luna daw, ayaw kay Andrew E. Pauline Luna, ayaw kay Andrew E. Kaya, lagi siyang naangwi. Ayan, no? Deformed. Diba? Angwi. Again, pag naangwi or deformed, si Pauline Luna, ayaw kay Andrew E. Yun yung mnemonics natin. Now, for your flexural stress, that is MC over I. Ano nga ba yung M? That is the bending moment. C is the parang by formula, that is the hindi ko maalala. So, C is, let me just check it my memory kung maalala ko siya. That is yung measurement nung iyong projected shape divide by 2 or the height divide by 2. Okay? C. Hindi ko lang maalala yung tawag. And then I is the polar moment of inertia. Okay? C, I. Inertial moment, that is I. Ay yung I depende yan sa shape. Kapag circular or annular or rectangular. Okay? SF is equal to mz over I. That is polar moment of inertia. Ito lang pala moment of inertia. Okay? Z is the polar moment of inertia. Now, ito na, para dire-diretso na tayo. For solid circular shaftings, yung flexural stress natin is 32M divided by pi d cube, where M is the bending moment. Okay? Ngayon, pag hollow circular, that is, wag yung tandaan to, malilito kayo. Ang tandaan nyo is dito. Okay? SF is equal to 32M dO over pi dO to the fourth minus di to the fourth. Yan lang ang tatandaan nyo. Malilito kasi kayo dyan. Now, for your rectangular, ito naman, rectangular, SF is equal to I, MC over I. Ano ba yung CH? Okay? So, let us simplify. M, C over I. Okay? Where M is, as is M, multiplied natin sa C, H over 2, kasi base times height, pag rectangle. And then I is BH cube over 12. Now, tingnan nyo ha, i-simplify ko pa. Further simplifying, M, 2, 3, okay, H times 12. Kasi kunin natin reciprocal. Tapos 2, BH cube. Cancel natin to, cancel natin to. This will be M, H, 6 over BH cube. May maka-cancel to. Okay? This will be finally 6M over BH squared. That is for your flexural stress ng rectangle. And we derive an equation. Now, we'll go with the torsion, yung twisting. Kapag pinipiga na siya, okay? Tinitwist na siya, yung shafting mo. Ngayon, meron tayo ditong mnemonic, okay? That is theta, where theta is the angular deflection. That is T L over JG. Okay? Sabi nila, kapag nakakita doon ng mani, tulo, laway, ni Jimbo, Guwak. Okay? Ayan, parang peanut. Pag nakakita ng mani, kasi mahilig ako sa mani, TL, tulo, laway, ni Jimbo, Guwak. Panis, di ba? Nakakuha na naman tayo ng bagong mnemonic. Okay. So, kidding aside, let's proceed. So, what is the torsional strength? That is for solid circular SF. Torsional to 16T over pi d cube. Nirive ko yan sa shafting natin. Okay? And then, pag hollow circular, 16T over, ito tandaan nyo kasi malilito kayo dyan. Pag ito. Okay? 16T. Okay? 16T dO over pi, dO to the fourth, di to the fourth. Okay? Ilang tatandaan nyo. Now, ito, kahit hindi nyo natandaan to, this is not yet mga hindi naman masyado binibigay sa board. So, ito na lang notations tandaan natin. Kapag epsilon, that is strain. U, that is Poisson's ratio. E is modulus of elasticity. Now, kapag G, that is modulus of rigidity. Okay. So, let's go with your strain and elongation. According to Hooke's law, yun, applying Hooke's law, meron tayong sa rigidity, tapos meron tayo sa elasticity. So, kapag elasticity, that is UC. Ito, sige. Okay? Pag nakita mo yung elasticity, UC. Okay? Ito naman, kapag rigid, sige. Okay? So, how will we know that? Okay? S is the stress, E will be the strain, and E is the rigid modulus of elasticity. Okay? And that differs from any material. Okay? And then SGE, where G is the rigidity, makukuha natin yan sa Poisson's ratio. Pakita natin mamaya. Okay, let me go with this note. Okay, yung Poisson ratio kasi natin is, tandaan nyo, ano, Poisson ratio is mu. Ito ko, ang ginagawa ko V. Okay, that is Poisson. Okay, E and G. Okay, dito natin makukuha yung formula niya. Para ma-solve natin si G, kukunin natin si E, i-divide natin to 1 plus Poisson. Ngayon, you have to remember this kasi this is very important. Kailangan nyo sa board exam to. You have to remember this formula. Don't you forget this. Okay. Now, ito rin yung kailangan nyo tandaan for steel. That is 30 times 10 to the 6 psi. And then, kapag steel naman, ang G rigidity is 11.5 to 12. But mostly, ang ginagamit is 12. All you have to convert, multiply nyo na lang, 0.101, 325, divide by 14.7. To convert it into MPa. Okay? Let's go with our notes. Okay? FL over AE. Ito naman, G. Ganun din. Simplify lang yung nakangili si Pauline Luna, ayaw kay Andrew E. Yan. And then, total strain energy. Hindi nyo na kailangan ito i-memorize. Okay, shear deformation, I have told you. Ito na lang yon. Okay. Poisson's ratio, ito rin yon. Pwede ito. Mas madali pa nga ito. Pareho lang yan nung kanina. Ito, hindi na kailangan itong i-memorize. So, thermal elongation. For thermal elongation, meron tayong kapag length, the change in length, change in area, change in volume. Okay? Yung mga alpha, where alpha is the thermal constant ng material that is always given pagdating ng ating you call this, Ito yung ating calculation. Now, for the strain, laging yan yung change in your length divided by the original length. Okay? Where that is the deformation. Now, tignan nyo ito. Okay? Kapag mainit daw ang, ito yung mnemonics ha, kapag mainit daw, you eat. Ano? You eat. Alpha Alpha yan. You eat. Okay? Kapag mainit or thermal elongation, mainit. Kapag mainit, you eat. Now, kapag mainit naman sa labas, you sit. You take your seat. Sit. Diba? Where A is the thermal constant ng material, delta T. Okay? E is the modulus of elasticity that is given for any material. Pero pag still, you should always remember and memorize. Now, for combined stresses, ito lang naman yung mga general formula. Okay? And then the shortcut. SA, axial, SB, bending, where your axial is always yung area projected nasa baba ng F, plus or minus, depende. Pag sinabi sa yung problem, MC over I, okay? For bending and torsion, gagamitin mo na si torque and then the moment. Magkaiba si torque and moment, okay? That is specified in the problem. Pag torque, that is the twisting moment, and moment is the pwedeng flexural or bending. Okay? Axial and torsion, paghahaluin mo lang naman. Okay? Yung axial and then the torsion, kailangan mo lang naman tandaan parati ito. Ito madalas na binibigay. Yung bending and torsion. You don't forget this one. Okay? Now, the notch sensitivity factor, it is the condition which causes actual stress in machine member under fatigue conditions. And you should remember this. Kasi binibigay ko sa board exam. Okay? Now, don't you memorize this one. Okay? But notch sensitivity factor is Q. Okay? That is maliit na Q. It is an indication of the degree of theoretical stress. That is non-unit. Okay? Concentration obtained under fatigue conditions. Okay? You don't have to memorize this one. All you have to memorize is this one. Okay? Where R is the radius of curvature and A is the factor of Q and T steels. A and T steels. Annealed and normalized steels. Q is quenched and hindi ko matandaan yung T. Basta yung T parang merong isang thermal, hindi ko matandaan. OQT. Parang ganun. So, magkaiba yung A nila pag sinabi yung Q and T steels. A and N, basta sigurado ko sa A and N, that is annealed and normalized. Okay? Basta ito quenched, yung Q. Okay? Should remember this too. And for another part, yung properties of steel, kailangan mo lang naman dyan tandaan itong E ni steel. Okay? Yung PSI lang. Yung English lang, ito makakonvert mo naman ito eh. And then ito, kailangan mo tandaan. Okay? Ito parati ko tinatandaan dito, yung English. Kasi madali siyang compute. And then the density. Okay? Don't you forget that pagdating ng steel. Okay? Pag steel, 490, 7850, pwede na to. Okay na yun. Yung aluminum, copper, binibigyan sa board. Now, for your beams, ito lang naman yung kanilang summary. But this one, kapag praktisado ka, nung formula, nung FL, depende yan, FL over Q, FL put long over 2, yung isa naman is WL squared over 8. Okay? Yun naman yung mga kinakabisado dyan. Okay? Simply supported, ito, kailangan mo kabisaduhin ito. Yan. Kapag fixed, FL over 8, walwal 12, 12 beses magwalwal. Ito naman, 8 beses magwalwal. Ito naman, kapag cantilever, ibig sabihin, isa lang yun dito, Si putlong lang, kasi makita mo parang putlong eh, putlong. 2 beses ka lang magwalwal. Okay? Uniform distributed, yun naman yung kailangan mong tandaan. Again, pag cantilever, parang putlong, o di putlong lang. Tapos 2 beses ka lang pwede magwalwal. Pag simply supported, that is, meron kang 2 support. So, pag 2 kayo ang suporta mo, so, 4 na putlong. Okay? Kailangan mo, kasi isa sa'yo, 2 sa'yo, tag-isa sila. Tapos dito, may katulong ka, kaya mas madaling beses ka magwalwal. So, 8 beses ang walwal. And then fixed, okay, may 2 kang katulong pa, kadulo, kaya lang, hindi sila gumagalaw. So, mas marami kang kailangan putlong, 8 putlong, and then 12 beses ka pwedeng magwalwal. Okay? That is the mnemonics na kailangan tandaan. Yun na yung mga ginawa-gawa ko lang na mnemonics. Okay? Now, for cantilever beam with end moment, kailangan mo tandaan, moment is equal to moment lang, the deflection is ml squared divided by 2ei, and then the angular deflection is mlei. Okay? Hindi naman masyadong binibigay sa board exam. Now, when you are loaded at the mid-span, that is ml f over 2, fl over 2, the deflection is 40 fl cubed, 384 ei. Ang hirap tandaan, okay? Ito rin, hindi naman kailangan yung tandaan kasi hindi naman yung binibigay. Now, with simply supported beam or with intermediate load, let us use this one. Okay? Tignan natin kung tatama ba yung mga computation natin. That is the maximum moment. Pwede nating maximum moment. Okay? A, B over L over F. Kaya lang, nasaan yung maximum force? Hindi natin alam. Kailangan nga kasi natin isolve yan using shear and moment diagram. That is the best way you can understand beams. Okay? And how you will get the maximum moment and maximum shear. Now, for let's go with rectangular beams. Again, ito yung dinerive ko kanina. Okay? Sa flexural stress, that is 6m over bh squared. Dinerive ko na to kanina. Okay? Now, for the shearing stress naman, PV, maximum shear. Maximum shear. Okay, V. Maximum shear. 3V over 2BH. Okay? Yan nakadali. You have to remember this one. 3V. Maximum shear. Okay, that will be all. So, let's go with the calculations. Para mas maganda natin maliwanagan tayo. Gamitin natin sila sa calculations. Okay, so